Hello and welcome. In this lecture, we're going to be implementing our own class member functions, move platform and rotate platform. We're going to see how we can set them up so they can take in arguments, and this is going to help us tidy up our code a little bit. Let's dive in and see how this works. So up until now, we've been using C++ functions that have already been created for us. We've been using tick, we've been using big and play in terms of writing their functionality, and we've also been using functions that other people have written for us. We've been calling them, such as getActorLocation and getName. Now, how can we go about creating new own functions to help organize our code and keep these functions small and everything much more legible? Well, we've got the basic building blocks already in place. By getting towards the end of the section, we understand a lot more about C++ syntax. So what I want to do is essentially create a new function on the moving platform that allows us to have, just in tick, say, call move platform. Why do I want to do that? Well, because being able to make a function call like this called move platform, it really speaks to what we're trying to do. At the moment, we've got a lot of stuff going on in tick, and I'm not entirely clear why we are doing all this stuff if I just come and take a glance at it. If I went into tick and saw a function that says move platform, well, then suddenly I have the context for what all this stuff should be doing, and I don't need a single comment to tell me what's going on. And this is going to be particularly useful when we add into the mix the possibility of rotating the platform as well. So how do we declare functions? Well, the declaration aspect is done over in the header file. That's where we basically say, heads up to C++, we're going to have a function that's going to look kind of like this. And then over in the C++ is where we actually define the function. We give it the body, we tell it exactly to C++, this is how the function works. And let's have a look at how we can do this. We've got a few examples of functions, and we've got begin play, we've got tick. And it's a good point in time for us to look at the different sections that we've got in our header file. We've got public and protected being mentioned here, and public being mentioned again. Now, what does this mean? These keywords with the colon at the end basically define a section of accessibility. These functions, where can they be accessed from? We've seen over in the getSafeNormal, this is a function that we're calling on an F vector, but we're calling on it from another class, not from within an F vector. So this means that the accessibility of this function needs to be public. Now, we'll leave aside protected just for the minute because it gets a little bit more complicated there. But there is another type of keyword that we can use, which is private. So I'm going to add, after tick, I'm going to add the private keyword. Notice that I don't indent these sections. And we're going to put a colon at the end. And that means that everything that comes afterwards until the next section, the next keyword that I put in here, is going to be private. So that means we've taken all of these variables and said, hey, no other class is allowed to touch these. And that's usually the best practice. We haven't done it up to this point because I didn't want to get things a little bit too confusing for you. But variables in classes should generally be their own business. It's one of the core tenets of object-oriented programming that we leave classes to manage their own variables, and we only access them using functions that the class denotes as being public. So what we're going to do here is we're going to add some more private functions in here because we don't want something like move platform to be called from outside of the class. We want it to be managed by our own tick function. So how do we define a private function? Well, we put it in a private section. So we've got our private keyword up here. I'm going to put it after our variables, however. And we start off with the return type. And if our function doesn't return anything, we just type void to indicate that there's no return coming out of this function. Then we give it a function name. So we had move platform was what we wanted. And then we give it some parentheses to indicate that this is a function. Open and close parentheses, and then a semicolon to finish off the line and say, okay, that's it. That is the function that I want to declare here in the header file. And all that does is says this is the shape of the function, this is the return, this is what parameters it takes, and the name, and which class it belongs to. Now, to actually give it an implementation, we have to define it over in the C++ file, so let's go over there. And at the end of the file, just outside of any curly braces, this is where we do it. We start again with the return type, so that's going to be void. Then, because we're inside a C++ file, we're not inside the curly braces of a class, we have to use the scope resolution operator to say that we're trying to define a function from within the moving platform class. So we type the name of the class, which is a moving platform, remembering that a prefix is there to say that it's an actor. Then we use : the scope resolution operator, and then we use the name of the function we're defining, which is move platform. And then we use the same set of parameters as we did in the header file. In this case, we had an empty set of parameters, so we just have the parentheses. And then instead of putting a semicolon at the end of this line, on a new line, we put an opening curly brace and a corresponding closing curly brace. And between these curly braces is where we put the code for our function. Fantastic. So what I want to do now is try and say, well, all of this functionality we've got here, and in fact, I'm going to delete the comments because we no longer need them. They were the pseudocode we used to implement this, but now it's kind of served its purpose. We understand what the lines of code are doing. I'm going to take everything but the move platform function out of tick and copy it and paste it into our move platform function instead. So this should work pretty much the same, because when we go into tick, we then call move platform and it just runs the same piece of code, except now we've bundled it into a function and it makes it easier for us to read and potentially reuse in the future. But if you do this, you will notice there is a problem. We are accessing delta time, and that is a parameter we no longer have access to because it was a parameter passed into tick. So if we want to get hold of that, we do need to have a parameter in our function. So when we define parameters, we have to do it in two places, just like when we define the function. We go back over to the header file, and between the parentheses of our move platform function, this is where we say what parameters we want. And it's exactly like defining a variable. You need to give it a type and you need to give it a name. So we're going to say it's going to be of type float, and we can just call it delta time. It doesn't have to be the same name. We could call it dt, we could call it time, but it's easier to give it the same name because then it's obvious to anyone reading it what should be passed in here. Then over in the C++ file, we need to match the list of parameters. So again, you can just do this by copying and pasting or by typing it out. If you type it out, make sure you don't make any typos because the compiler will complain. So we're going to have a float called delta time passed in as a parameter, or defined as a parameter to move platform. But we haven't actually passed it in as an argument to move platform in tick. And you'll see I've got a little red squiggly line here. If I hover over it, it says there's too few arguments in the function call, because I've defined it in the header file and now in the C++ as well as requiring one parameter of type float. So I must provide that parameter. So I'm going to make sure that the parameter I'm providing, the value that I'm providing, comes from the delta time variable, or the delta time parameter from tick. So we're threading the value gets passed into tick, it then gets passed into move platform and ends up in our parameter in the move platform function, where it can be used to execute our move platform functionality. So I'd like you to create your own rotate platform function that we're going to call from tick. So you're going to add it to the header file like we've done for our move platform function. We're going to add it to the C++ file in the same way as well. So take your hints from the way we did it for those functions and then call it from the tick function. Make sure you pass in delta time and you define any parameters to allow you to pass in the delta time, and implement the body of the rotate platform so that it logs out a message. It's not actually going to rotate the platform yet, but as a placeholder to make sure that that is actually getting called, print a log message using the UE log that we've learnt about. Pause the video and have a go. Okay, welcome back. So we're going to start off in the header file, and we're mostly going to be doing the same as we did for our Move platform. We're going to put it in a private section so that it's only accessible within our class. We're going to give it a void return type. We're going to call it rotate platform. We're going to open up the parameter list, and in it we're going to put one parameter, which is going to be of type float. We're going to call it delta time, and close the parameters and finish off with a semicolon. Now, most of what we do over in the C++ file is exactly the same as in the header file. So I'm actually going to copy this line, go over to the C++ file and show you what is different. So I'm going to go to a new empty line at the end of the file, paste it in. And then what's different is over here we need the scope resolution operator in the class name. So we're going to have a moving platform : rotate platform. Then we have the parameter list, and then we don't need the semicolon on the end. So we remove the semicolon, add in a new line, and add our curly braces instead, and a new line between those two curly braces. So what we want to do in here is print out a log message. So I'm going to type log, hit enter. It's just going to be a simple display message. And in the text, I'm going to put the name of our platform. So it's going to be %s. Then we're going to type rotating ... and then I'm going to pass in the name. Now, we could put this into a variable, but because it's quite a short line here, I'm just going to type star get name and then put the parentheses so that we're calling, essentially here, calling the get name. That is the expression that gets hold of the f string. And then we are converting that result to put into our log message. So from all of our platforms, I'm expecting to see that rotating is printed, but this will only happen if I actually call it in tick. So let's go up to the tick function. After move platform, I'm going to add a new line and call the rotate platform. And we need to, you see, when I open up the parentheses, it gives me a hint that I need to pass in an argument for delta time. So again, we're just going to pass that same delta time variable from within here. And like I said, the names here don't have to be the same. So this delta time needs to match with the delta time within tick. But we could choose to call the variable within rotate platform dt instead. And anywhere we use it within rotate platform, we'd have to use dt. The name of the parameter and the argument can basically be different. So let's hop over into Unreal and hit compile. Because we've made some changes to the header file, the compilation will be slightly longer than when we just changed the C++ file. And once that's completed compiling, we're going to go ahead and hit play and open up the output log. And you can see that we are indeed displaying log messages about each of the platforms rotating. So it looks like our function is effectively getting called in tick. Great stuff. Now we understand how to create our own functions that are members of a class. It's a very useful tool for reusing our code, but also for organizing it, just like it was in Blueprint. I'll see you in the next lecture.